No, not weight, because weight is mass with the acceleration due to gravity. Well, there isn't
Yeah.
an acceleration due to gravity because gravity doesn't accelerate anything. Gravity
But
is the acceleration, according to Einstein.
no, 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 no. Right. The mass is the actual raw
What do you
stuff that
mean?
you
No,
have.
no. What do you mean? No, no.
The
Gravity as
listen. The mass is the raw stuff that you have. The weight is the force acting upon it.
what force? There is no force.
That's what you measure with a scale or a Newton meter.
There isn't a force there. There's no. You
That's what
can't
weight
claim there's a
is.
force
One
there.
That's
fair.
definitely
That's what
geometry,
weight
No.
mate.
is.
Just want to introduce.
I know how you. I know how physics defines weight. You're claiming that there is an additional force and an additional buoyant force cancelling each other out, but you can't prove that. And science only deals with the physical and the natural world, not the supernatural.
Weight is the proof of that.
Pardon?
The fact that things have weight is the proof of that.
No, mass. You're describing weight as mass
No,
interchangeably, and they're not the
no,
same.
no. You're misinterpreting what I'm saying. So when we talk about mass, we're talking about the stuff that's there. We don't refer to mass in like. It's the best way to put it. Um, so you measure mass in terms of kilograms. You measure weight in terms of newtons.
Yes,
Yes, they're different things.
they're not. They're describing the exact same thing.
No, they're not. It's a bit
They
like how
are.
when you did your experiment, you said this TDS meter measures the density of the water. It doesn't.
It measures the particulates per volume, so it tells you how many particulates there are in that sample.
It tells you how much it thinks, as a rough estimate, is dissolved in the water.
Yeah. So when I add something
Right.
to it and that number then goes up, it doesn't really matter by how much, it just matters that it moves and it's not the same value as before. And that's all I was demonstrating.
Right, but all you're determining there is that stuff is dissolved in the water. You're not
Correct.
determining that
And that
the.
was the cause. That was my presumed cause, that something dissolved in the water.
But you didn't determine that the density of the water increased.
But you saw me add mass. So long as there's a change, it doesn't matter what the value is, so long as there is a change and you saw me add mass. It's
But
not a
your
contentious
experiment
point then.
did not prove that. It did not show that you added density to the water.
It did. You saw me add the salt when I sprinkled it in.
Then you need to measure it to show
I
that.
did. I showed a relative change in the density.
No, you didn't.
Yes, I did.
No,
I
you
measured it.
didn't. You
Yes,
showed a
I did.
relative. You showed a relative change in the amount of solids that were dissolved into the water.
Okay, so let's accept your position and say that I didn't prove that the density changed. I recorded myself sprinkling salt into the solution. Are you saying that I sprinkled salt in, but it didn't change the density?
No, I'm saying that what you thought you proved, you didn't prove.
I did prove it. You saw me add mass. You saw the change in the number on the reading. You
So
saw
what?
me add the mass.
Okay. What you were able to prove with that experiment is that there is a correlation between salt being added to water and an egg rising.
No,
That was
not
it.
correlation. The definition of the independent variable is the presumed cause that the experimenter manipulates to test the effect on the dependent variable. I did manipulate something, and it happened to be the thing that I added. So it's not correlation; it's causation.
You adding salt to the water made the egg rise. That's all you can say.
No, I proved it. I demonstrated it within scientific method because the definition of the independent variable, the presumed cause, is the thing that I manipulated, and you saw me manipulate it by adding it. That's the independent variable. It's not correlative, it's causative.
But you didn't show that.
I did. I recorded myself pouring in the mass.
Yes, you showed yourself pouring salt into a glass and then claimed that it changed the density of the water, which you did not show.
I did. I poured mass into the water.
No.
So, are you denying that salt is more dense than water and it didn't change the density then?
I'm saying what you think you showed and what you claim you showed are not quite what you actually showed.
They are. I showed it on the camera, and unless you deny physics and say that the salt isn't less dense or isn't having an effect on the density, even though you see me adding it and the egg move, then I'm going to ask you, what kind of batshit crazy are you?
That's not what I'm saying. I'm not
It
saying that
is.
salts
That's
being.
exactly what you're saying. You're saying that I don't quite prove what I claim I prove, yet you see me pouring mass in. So what the fuck do you think I'm proving if you see me add mass? What am I not doing that's right?
Right. The salt in the water, when you pour it in, some of it will have dissolved and some of it won't. The stuff that didn't dissolve straight away fell to the bottom of the glass. Some of it did dissolve. What you didn't show was how much of it dissolved by showing the change in density of the water.
I did. I measured the
No, you
bit that
didn't.
dissolved.
No,
The
you didn't.
TDS
You did
meter
not
measures
measure.
dissolved. Listen, the TDS meter measures the dissolved solids, and the stuff that didn't dissolve was set at the bottom of the glass. But all of the mass that was added in its either dissolved state or not dissolved state all went below the egg. So I showed the change in the dissolved bit with the meter, and the undissolved bit was still left at the bottom of the glass. I did exactly what I claimed.
Claimed that adding salt changed the density of the water. You
Do you
showed
do
that
you
all that
dispute that?
happened was that stuff was dissolved in the water. You did not show that the density actually changed.
Yeah, I did, because if stuff dissolved in the water and the parts per million count rose even by 1, then that changes the density of the liquid per volume.
Do you understand what a TDS meter does?
Yes, I do. It measures the conductivity by providing a small current through the prongs.
Okay, what does that have to do with density?
Because if you increase the salinity of the water, it increases the conductivity of the water, and it demonstrates that you've increased the mass and therefore the density of the liquid.
No. You've
Yeah,
demonstrated
it deals with the dissolved part.
you've demonstrated that the water is now more conductive. That's it.
Yeah, and why would it be more conductive?
Because the thing that you added to it carries an electric charge better.
Correct. So if the conductivity increases because I added salt to the solution and I measure an increase in that conductivity because of the mass that I added, you can't deny that I changed the density because you can see me adding it and I measure a change in the salinity because the conductivity value is increased. If you didn't see me add the mass, you might have a point, but you did see me add the mass, so you have no point. I demonstrated the change that you claim that I didn't.
So in to quote you, since you're so keen on your definitions, right? Density. Define density for me.
Mass per volume.
Okay, the volume increased, didn't it?
Minusculely, yes.
Okay, and the amount of salt that you added would have increased the volume that was in that glass.
Yes.
Okay, so there's a correlation there as well, isn't there?
Correlation in there as well. We're not having the first one as a correlation. That was a cause. So we're going to say, yes, you can correlate. It's the same as like Boyle's gas law. As the temperature increases, the pressure increases. So yes, that bit is correlative, but we're not going to describe it as a correlation again. We're going to describe it as a correlation in the first instance because the other one was a cause.
What I was getting at is there was an amount of volume inside the glass. When you were done pouring salt in there, there was a bigger amount of volume inside the glass. Right?
Yeah, I've agreed. I've agreed.
Okay. So, to quote from your conversation with Kosho, you were talking about taking chunks off of bricks. If you chop a chunk off of a brick, you reduce the volume, yeah?
Yeah.
But you don't reduce the density of the brick, do you?
No, because you're reducing the mass and the volume at uneven rates because the mass per volume is high on a brick. So each chip that you take off, you're taking off more mass than you are per volume, but it's still a relative scale that's sliding down.
So it's easy to show that when you poured the salt into the glass, the water level rose. It took up more volume. So what
No,
effect did
that's
that actually have on the
that's
density?
no, you're wrong. That's not easy to show because if it was easy to show, it would be obvious in the video. So how is it easy to show? Can you demonstrate that claim, please?
If you do the experiment scientifically, you can show that.
Not
This
really.
is, this is what I'm
It's a
saying.
minuscule change. It's literally
Right.
minuscule.
But you didn't test the density of the water.
I
That's
did.
the
I
issue.
demonstrated that as I increased the mass, the conductivity increased because the salinity rose, and that you see me adding the mass. So unless you're going to deny that salt as a mass will have changed the density value, then I don't know what else. There's no conversation here.
So
You've got to
okay,
literally deny that salt.
You're committing an equivocation fallacy by basically claiming that conductivity equals density.
No, I'm not equivocating. What I'm
Yes, you
doing is
are.
I'm demonstrating that I added salt and that is mass, unless you deny that salt's mass. And by measuring a conductivity of the salinity of the water, salinity is a measure of the amount of salt in the water. You realize that, right?
Salinity is, yeah, but you didn't measure salinity.
Yeah, conductivity. As conductivity increases, the salinity increases as well. It has to.
Yeah, those two things are separate things, though.
One's a direct cause and one's a direct consequence of salt being added. Add salt, you increase the
Uh,
salinity. That's what salt is, salinity.
Salinity is specifically the amount of salt dissolved in a body of water.
And it's measurable by the conductivity of the water.
Yes.
So
Because,
you say that I'm falsely equivocating. Actually, I'm accurately and correctly equivocating. But that's not the point. The
yes, you're
point is that
identifying that there's an amount of salt dissolved in the water, but what you're not
Of fucking
identifying is the
course.
density of that water with the salt dissolved
so.
in it.
So then you're denying that by adding the mass in the first place on camera, you're denying that that has any effect on the density, right?
No, I'm saying you didn't.
Then what's the issue?
Right, you didn't correctly identify that the density had increased because you even accept that the volume increased when you poured the salt in.
If the density didn't increase, the salinity of the water would have stayed the same. In
Think
fact,
about it
actually,
like
no,
this.
that's not even right. If the density of the water didn't increase, then you would have to argue that I did not add mass to the water.
Think about it like this. There are a bunch of water molecules in the glass. You then pour in a bunch of salt molecules and
Yeah.
they push each other apart. Is that space now more dense when those things are pushed apart?
Well, if you're going to answer that it's not more dense, then I don't know how you can argue that.
Well, isn't density defined by how close those atoms are packed together?
It's defined as mass per volume.
And mass is
Increased because I poured stuff in.
specifically what is mass? It's the atoms, isn't it?
Well, that's $1 million question. Nobody really knows what mass is. Some people describe it as the amount of matter per volume. Some people describe it as the measure of density or denseness of the thing. Mass is not something that we can define easily. It's something that seems to be deliberately confusing.
Oh, I see. So you're using terminology that you don't know the definition of. So that's pseudoscience at this point.
Oh no, I know that mass is one of those difficult to define words, but that's the way that you guys describe it to other people so that we understand what we're talking about. But the word mass is often and is conflated with the word mole, the concentration of a solution. So whether it's mass or mole is kind of irrelevant. The point is that you see me adding mass. And if you deny that me adding mass changes the density, even though I showed a relative change, I don't know what to say for you other than you're stupid.
I'm saying I'm not denying that it changed the density. I'm saying what you showed was was a change in the TDS meter reading, which is basically a change in conductivity. You didn't show and test for a change in density.
So you deny that adding salt that dissolves or otherwise doesn't, whether it dissolves or not is irrelevant. You deny that adding salt changes the density of the liquid. We're done.
No, that's not what I'm saying.
It is. You're saying I didn't prove it, yet you see me adding it and you see a relative change in the salinity. And the salinity is a measure, the conductivity is a measure of the salinity of the water. So the salinity increases, that mass increases in the water. I don't know how you can argue that I didn't prove something. I did. You saw me do it and I measured it.
You changed several things. You measured one
No,
of them and claimed it was
no,
the other.
no. I changed one thing and that caused an effect. And the thing that I changed is known as the independent variable. It is the thing that the observer, the experimenter, deliberately manipulates to test the effects. I
What was the
deliberately
one
manipulate.
thing that you changed?
I added mass.
But what was the one thing that you changed?
I added mass.
So you're saying, but you also added volume. So you didn't just change one thing.
That was an effect.
And you also added conductivity to the water. So
Yeah, that's
you
because
added.
salt is conductive. It's a property of salt.
Okay, so you didn't change one thing, did you?
But conductivity is not a factor in this. I wasn't passing a current through it.
Yes, you were. That's what the TDS meter does.
To measure the result, the relative change. If you think that current had anything to do with the test, can you show me where the current was?
In the TDS meter that you used.
That wasn't part of the test. That was part of the demonstration to prove that there was a change. Where was the
Right.
current in the test?
So you're using conductivity as a claim that you changed density.
No, I'm using conductivity to prove that there was a change in the density. It's not part of the test. It's part of the results.
You can't test one thing and then claim you changed another thing. That's not how it works.
No, I'm not testing one thing. I added mass, and the mass happened to be salt. Salt's conductive, and with a cheap TDS meter, we can demonstrate there was a change. So you see me adding mass. I demonstrate by proving that there was a measurement change.
I
It's
see
not in
you adding
dispute.
mass. I also know that you added volume because you even accept that. So you add mass and then you test for conductivity. Okay, where did you prove a change in density?
Where did I prove a change in depth? When I poured the salt in on camera. Not when I measured it. That was proving that there was a change. But when I added mass, that's proof that I changed the density. Because
No,
unless
all
you...
you proved is that there was more volume in that glass.
Well, it is how you disprove me, right? Rather than claiming it, you go and do the test yourself. And if you think I did something wrong, go and do the thing that you think I did wrong, do it properly, in your opinion, and then get a different result. And I challenge you to do it, Wardy. If you think that I did something wrong, go and do it yourself and prove me wrong. Because until you do, Wardy, all you're doing is being rhetorical, and it's just shit. Go and prove me wrong. Nobody's
To
been able to
every
do
flat
it.
earth argument for the last decade.
Wardy, go and prove it wrong. Don't spout to me as though you're some kind of authority. Go and prove it, because that's what science is about. If I've got it wrong, go and prove it.
Well, it's easy to show that a TDS meter doesn't
Well, go and do it
measure
then.
density.
Go and do it then. Go and
Go and
prove
pull
me
the
wrong.
Yes,
instructions
please,
out that you
Wardy.
already
I've
have.
seen Tony's do it. Where's yours?
Yeah, go and prove
Go-
it wrong. Don't just claim it. Go and
Go and
prove it.
pull,
It's,
go
yeah,
and
you've got
pull
a
out the
pint glass, haven't you?
instructions.
You've got an egg and you've got a bit of water. Go and get whatever device that you think was the correct device, add salt, and then get a different result by measuring something different, and then demonstrate that I did something wrong that got a different effect, or that my claim was incorrect. Demonstrate it.
The instructions for your TDS meter.
Go and
Pardon?
show us, Wardy. Show us them.
Show us from the instructions.
You
where
know,
it says in that
you
TDS
show us,
meter
Wardy.
that it
No,
measures
Wardy,
density.
if you think that the TDS meter was something that was wrong, go and use the correct thing that you think that demonstrates the point properly, and then get a different result with the different results, and then show that I did something wrong. Until then, Wardy, you're just spouting off because you don't like the results, and that's it.
Surely you could just take the TDS meter out of the equation and just pour salt in.
It
Or you
doesn't
can
have to
just
be in there.
realize
It's
that
fucking
you
obvious.
can't just be right
The only
because you
reason
want
why
to
I did
be.
that TDS meter was to demonstrate there was a change, and even if it only went up by one, the fact that I added salt means that it is more dense than water, and to show a change. Now, it doesn't matter how much it is; it just matters that it goes up a little bit, and that's what I demonstrated. Because if it didn't do it, somebody like Wardy would say, "Well, how do you know that the salt had any effect?" Well, I showed a change, so I measured a change. Now, it doesn't matter that you say that the change isn't the change that I claim it is, because if you go and measure the change that you claim it is, see if you get a different result when you measure the change that you, and it's not going to change it.
What I'm saying is you measured a change in conductivity and claimed it was a change in density.
Do you think it was a change in density, Wardy?
I think there was also a change in density in the water, yes, but that wasn't what was shown in his experiment.
Or go and show something different and then show how that difference made any difference to the results. Because don't forget, experiments is about demonstrating cause and effect. The bit you're talking about is how you calculate the difference. Well, I'm not interested in the calculation bit, but I'm prepared to listen to you to see if you can demonstrate that I did something wrong. If you can't demonstrate it, my results still stand. That's what science is about.
Wardy, the better question here to ask you is why don't you want to go and redo it?
Yeah.
So on face value then, based on the results that you've shown from your experiment, we can draw some sort of conclusion that there's a connection between conductivity in water
No,
and
not a
the
connection.
position of an egg.
Not a connection. We need to understand the definition of the independent variable in a scientific method, in a scientific experiment. The independent variable is the thing that the one variable that the experimenter thinks might cause a change. That's why it's called the independent variable. You will manipulate that cause in a test to see what it does, and then you will observe the effects to see does it do what you think it do. So it's not a correlation, it's not a connection, it's a cause, Wardy. You need to understand what the independent variable is.
Okay, so you caused the TDS meter to register a different amount of conductivity in the water, and the egg rose.
Yeah.
And then you claimed it was a change in density that caused the egg to rise.
Yeah.
So your hypothesis was flawed.
So my hypothesis was flawed.
Yeah.
Do you know what a hypothesis is, Wardy?
Yes.
Tell me what a hypothesis is.
You presumed the cause to be density and then measured the salinity.
No, a hypothesis is an expression of a cause and an effect relationship. The cause was the density of the liquid, and the effect was that there would be an acceleration. So I manipulated, whether you agree with the measuring device or not, I manipulated the density of the liquid by adding mass, and it caused an acceleration. So the cause and the effect was within my hypothesis. So when you said that my hypothesis was not correct, well, it is correct because you don't understand what the hypothesis is. It's an expression of a cause and an effect relationship, not a calculation, not a measurement of an effect. It's the cause and the effect.
Yeah, but that wasn't the one cause that you changed.
So demonstrate that I did two causes and demonstrate the other cause that you think I did, but keep the other one the same. I mean, you've got a pint glass and an egg and a bit of water, haven't you?
Well, why do I have to demonstrate that your experiment doesn't work the way you
Because
think
you're
it does?
claiming that I've done something wrong, and I challenge you respectfully to go and prove that the thing that you claim that I did wrong, A, had any effect, and B, the effect cancelled out or made void my test. It's very simple. A pint glass, a bit of salt, and then just do it with whatever you want to measure it with. But don't forget the cause and the effect, not the calculation, not the interpretation, not the explanation. It's the cause and the effect. So what I'm saying to you, Wardy, is no matter how I measure it, no matter what tool I use to measure anything, it doesn't change the cause and the effect relationship. It changes your explanation and your interpretation of what you think's going on. But remember the independent variables, the presumed cause. So regardless of how you calculate or explain, it doesn't change the cause and the effect. And that is what I demonstrated.
In your words, your independent variable was not the thing that you tested.
I don't need to test it. I need to manipulate the independent variable to see does it cause the effect that I thought it would cause. And my prediction was that if I changed the mass or the density of the medium, it would cause an acceleration. And it did.
Yes, you predicted that you would change the density of the medium, and then you measured the salinity of the medium.
No, it was an acceleration. My cause was changing the density. My effect was an acceleration. The egg would move. That's what happened.
Okay, if you say so.
Not me. Scientific method. Your hypothesis is the definition that you need to understand because that's the expression of the cause and effect relationship. And then you demonstrate it by manipulate something and it causes an effect. Then if the thing that you manipulate is the cause in scientific method, if you're going to say that it's only correlative or that it was some other unicorn farts that actually did it and I got it wrong, then it's down to you to then go and demonstrate that I got it wrong, but do it within scientific method. Correctly identify your observed phenomena, correctly identify a valid hypothesis where you correctly identify your IV, your DV, your controls, and what your null hypothesis is. Then you perform your test and see does it do what you say it would. But the thing is, if you add salt to the water and the eggs in that middle bit like it was on mine, no matter how you calculate or measure or whatever, it's still going to move when you add the salt. So I don't see how your calculation or your explanation will change anything in the test because the explanation and the calculations are not part of science. That's part of the supernatural world, isn't it? It's the world that doesn't actually exist.
Okay, measuring the density of a liquid can be done by having equal amounts of, say, normal water and salt water.
Yeah, would adding salt to water increase the density?
I would expect it to, yeah.
Yeah.
Okay.
So why is it even an issue?
Yeah.
Because that's not what your experiment showed.
It is. It's exactly what my experiment showed.
That's what he
you're
did.
Trying to claim is, what you're trying to claim is that my experiment can be calculated or interpreted some other way. Okay, well, so that you can interpret it any way you want, but it isn't going to change the cause and effect relationship, and it isn't going to change the identity and the naming of the independent variable being the mass that was added, the salt that was added. So you can interpret it any way you want, but it's always going to come back to the independent variable definition. It's the presumed cause, and it's the thing that I manipulate. So you can calculate anything you want, you can measure anything you want, and you can claim anything you want, but it's always outside a scientific method, and that's pseudoscience. Go and demonstrate it, Wardy, if you think I did something wrong. Prove me wrong. Don't just claim it, prove it.
Well, the way that you would demonstrate this is to do the same experiment with a fish tank. Something that requires a substantial amount of salt to actually change the...
Oh, fuck off. So you don't think that the volume of the salt made any... You think that the volume of the salt was some kind of a critical factor here? Come on.
No, the reason why I'm suggesting using a larger amount of water in this case is because you will be able to actually show that there is a volume change.
And then when you've done it with a fish tank, Tony, they'll want you to do it with a swimming pool.
I did it with a
5
5-litre canteen of water, and I used quail eggs.
Yeah, welcome to what Soundly went through for 3 years with his bridge.
Oh,
Yeah, but
hey, the Soundly Bridge 3-year thing. Where's that file? Have you brought any more pictures with you?
But here's the thing, though. With the Soundly Bridge thing, we've had people try and repeat it and not got the same results, right? We've been through this conversation with Dave Rakialife and Andrew John. They didn't get the same results, right? But you can get the same results if you go and get a pint glass, a bit of water and an egg. And then all you got to do is pour salt in, right? I don't care how you calculate it. I don't care how you measure it. I don't care what you interpret what's going on. It's repeatable. Soundly stuff isn't repeatable, and that's why he got the shit that he got for so long.
Soundly offered to go and show them how he did it, and nobody took him up on his offer for 3 years.
That's not
How
true.
he did it?
Now all of a sudden,
That's
Soundly
not
isn't
true.
back
He's lying.
there.
People
Everybody's
did go
claiming
back.
bullshit because they can't do it themselves.
Dave's there.
No, he's lying.
Oh, dear.
You know that Dave Rakier has done it, and you know that Andrew John has done it, and did not get the same results. So his claim that people didn't take him up on it is not true.
They did not take the same picture, did they?
What do you mean take the same picture? How could any picture ever be the same in atmospheric conditions?
Because what you're looking for is the accentuated curve. So you need to take a picture of the other end of the bridge from where you're stood. Just taking a picture of the first 100 meters is not going to show it, is it?
Nobody has been. Andrew John's. I showed you Andrew John's footage,
It won't
and he
damage.
took it from the exact same place with the pylons, and it didn't show what he claims it shows. Do you want me to show you it again so that you can see it?
He's just wiggling away from the egg
will.
experiment, isn't he?
Not wiggling away from nothing.
Changing the
Yeah. So
subject.
Wardy,
I'm
let's
sorry,
get
but
some.
the
let's get
standard
some-
of evidence seems to change here depending on which side of this debate you're on. Flat Earthers seem to argue that they can just throw bullshit out and then claim a victory from it. Whereas
I'll tell you what,
when
Wardy,
You're
go
the
and
one
do
that's
the egg
throwing bullshit
experiment
out and
yourself.
claiming a victory.
He
Hang on,
added
listen,
salt
I'm
to
challenging
the
Wardy.
solution.
let me
Wardy,
finish
I'm
my
challenging
point.
you
Water
to-
and claim the
Wardy.
density.
Whoa.
Let me finish my
Increase
point.
the density.
Hang
Let
on.
me finish my point. Let me finish my point. When Soundly first started taking pictures, everybody called bullshit and said, get a different angle, get this, get that. So he went back and back and back. And this is what's going on here. I'm basically saying, go back and do it a different way. And you're
No,
saying, no, you do
Well,
it.
You do
I've
it.
already
Yeah.
proved my
Wardy.
point, dude. You're the one that's claiming that there's an error. Okay,
No.
it's only
No,
a pint
sorry.
glass, an egg,
You do
and
it.
water.
I've shown you the flaw in your experiment. You
You're
go
the
and
one
fix
making the claim. I've
You've
made my
claimed
claim
a
and I've
flaw.
demonstrated it. You're claiming that I've done an error. Well, go and demonstrate that the error made any difference according to
have.
your interpretation, and let's
You
see
have.
do you get a different effect.
Your inability to see the error is not my problem.
No, your claim of the error doesn't exist, and I'm calling you right now in front of an audience to go and demonstrate that what you claim I did wrong had any effect whatsoever on the cause and the effect. And what it will do is exactly the same. We all know it'll do the same thing. And what you'll claim is that there's magical fairy forces called gravity doing something. and somehow infer some additional cause. And then you'll come back to me and I'll say, yeah, but the independent variable is defined. It's the cause, the presumed cause that the experimenter manipulates deliberately to test the effects on the dependent variable. So you're going to come back with an inferred cause, and then I'll remind you that that's not the cause. That's all that's going to happen. That's why I'm trying to get you to do it. Go and try and prove that your claim that I did something wrong has any effect on the cause and the effect, and it won't. Or you could just drop your claim and say, do you know what, I can't be arsed, and I'll just drop it because I know that it's going to do the same thing.
Tone,
Yo.
could you do the same thing with sugar and then it should not affect the conductivity?
Is sugar more or less dense than water?
Well, a 2 pound bag of sugar weighs the same as a 2 pound bag of salt.
Yeah, you need to see whether or not sugar is more or less dense than the water, and I don't know whether it is or it isn't. It's only a Google search, but
Well, you'd just have to put more in, wouldn't you, if it was less?
I'm assuming it's more dense than it. But how would you measure the change in it? You'd have to find a way to measure the increase in mass, and that the TDS meter wouldn't do it. There'll be a way of doing it, but maybe that's what Wardy can do to debunk me. Why doesn't Wardy do that exact thing with sugar and measure the change?
Yeah.
Even if,
It's a good
even
idea.
Even if sugar is less
Thank
You
dense,
can use your little meter as well, Wardy, and check your instruction manuals and all of that sort of shit. You can get all of that on video. Yeah.
But I'd be interested, Wardy. I'll challenge you. Do it with sugar and measure it any way you want, and see what does the effect. Make your prediction, make your hypothesis. Go through the process and tell us what's going to happen when you add your sugar and how you're going to prove it, and let's see what happens when you do it. Be dead good, that Wardy.
Challenge. Do a video challenge, Tony.
Yeah. We
On
could
a
do
community
it. Like,
post.
Well,
Yeah.
this is the video challenge.
Could
This
do
is
it
it right
here,
now.
Rob.
We're in it.
I've got
Yeah.
no eggs.
why does the density of sugar matter?
Because you need to know, is it more dense or less dense than the water? And I'm assuming it is more dense, but I haven't checked it. But I'm assuming once it
Yeah.
dissolves,
I thought
it is.
I thought your claim was that you poured stuff into the glass, and therefore you added more density.
Yeah, but as it's dissolving, because it's dissolving as the minute it falls in, right? I'm assuming that sugar is more dense than it, and if it is, great. It's going to cause a change. It's going to cause an acceleration, isn't it? And then whichever way it goes, doesn't matter, because you're still changing the density of the liquid, and it's causing an acceleration, right?
But you told Kosho that all that salt that you poured in went to the bottom of the glass and pushed the egg up.
That's right. All of the salt went below the egg because all of the salt is more dense than the water.
So all of the salt fell to the bottom of the glass, except
No, some
it
of it-
didn't because
some of it
TDS
fell
meter
to-
showed a rise.
Some of it
Yeah.
went to the bottom of the glass. You could see it. All the stuff was dissolving as it went down. So, I don't know, 50-50 maybe? 80-20? I don't know what the percentage is. I just know that some of it changed into the water because it dissolves. And that's the bit I measured. I measured a change.
Well, sugar should not alter the conductivity of water, should it?
I don't think so. But then, if that was the case, then the TDS meter wouldn't measure a change, and they're only about £4. So it's not exactly expensive, but you'd need some other way of measuring it. And I mean, I don't even see why it's relevant. If you add mass to it and it causes an acceleration up or down, then you're adding mass to it, right? You're changing the density of the liquid, and it causes an acceleration. But because they demand that you measure something and prove it, then you've got to find a way to demonstrate it, right? And whatever that way is, who cares? Within science, it's just the cause and the effect. It's not the cause, effect, and the measurement to prove it. You see it. That's why I did it on camera. So are you going to repeat the test, Wardy, and see if you get different results?
Oh, is he gone? What's
No, he's still there.
Wardy?
I think
It's not my
What?
test to prove. It's yours.
it's your claim. You claim that I
You've
made an
a
error.
claim.
You claim that I made an error.
I didn't claim it was observably so.
Okay, so demonstrate that
prove
the
it
error
wrong.
that you claim that I made changes the results, the cause and the effect.
Oh, that's for you to prove.
It's not. It's your
No, it's
claim.
your
I've already
claim.
demonstrated my claim.
Oh, that's how science works. If you want your
No,
theory
no, no,
to
no.
be proven,
Fuck's sake.
So he that makes the assertion demonstrates it, right? I made the claim that if I manipulated the density of the medium, it would cause an acceleration. That was my claim. I did that, and an acceleration occurred, up or down, doesn't matter which way. Something moved, right? You're claiming that I made an error, and that error would do something. Okay, we'll demonstrate it. And until you do, Wardy, sit back down, son.
You didn't test an increase in density. That's
You
just
saw me
common
add the
knowledge.
mass. You saw me
Common
add the
knowledge.
mass.
Read the instructions on your TDS meter.
Forget the meter. You saw me add the mass.
What do you mean forget the meter? That's the thing you're using as your proof.
No, you saw me add the mass. That's the proof. All that does is quantify a change, but it doesn't prove that I added anything. You saw me add it. One sec. Yo.
Drop TV off anyway. Catch you guys later.
Oh, see you later.
Go and do the experiment yourself, Wardy.
He's gone.
That guy is an idiot.
I've got to go.